There are hundreds of billions of these lost, wayward, poor, wandering planets out in our Milky Way galaxy with no parent star to warm them up.
Cold, dark, quiet. Because planemos have no sun, they are worlds without days or years. They keep vigil through an eternal night. Planemos are solitary wanderers, sentinels of the galaxy. Just because it's out there drifting in space doesn't mean a planemo is dead.
If the planemo is a rocky world, it could well have life on it.
A small rocky planemo without an atmosphere will slumber in extreme cold, far colder than the coldest winter day on our own South Pole. But a planemo large enough to retain an atmosphere traps the heat generated when the planet was first formed. It is the ultimate greenhouse effect. The heat and energy comes from the molten core deep inside the lonely planet. If the planemo is a gas giant like Jupiter, it may have a system of moons. The gravitational pull between the planemo and its moons creates friction, causing the interior of the moons to stay warm.
These moons could also have life on them, in the same way that Jupiter's moon Io has volcanoes and has a lot of heat energy being generated by interactions with Jupiter and the other moons.
If anything lives here, it will be single cells, like common bacteria found on Earth. Not complex life forms. Without a sun to provide photosynthesis, these tiny organisms derive their energy from the chemistry in the soil of the planemo, or its moon. On Earth, there are similar conditions. Colonies of bacteria are found deep within mine shafts in South Africa. They have no access to oxygen nor light and survive entirely on the chemicals they make from the surrounding dirt. Their metabolisms are extremely slow, and they reproduce only once every 1,000 years. If life dwells on a sunless planemo, it could be organisms like them, marooned when their planet was young. While planemos slumber undisturbed, there are worse places to be in the universe. Like in the company of this lethal pulsar, some 980 light years from Earth, in the constellation of Virgo. From afar, a pulsar looks like a blinking light. But up close, pulsars machine gun their surroundings with deadly radiation. They are no place for planets. Yet something interferes with the precision of this pulsar. One explanation is that the anomaly is caused by a planet. But many astronomers are skeptical that planets orbiting a pulsar can exist.
The reason that's a problem is because pulsars are formed in these incredible explosions.
When a red giant star explodes, a titanic fireball known as a supernova unleashes as much energy in 1 minute as our sun generates in its lifetime.
When a star goes supernova, the shockwave is so immense, it's hard to imagine any planet surviving that.
When the cosmic dust clears, all that remains is the crushed core of the red giant, pulsing in the heart of an expanding debris field. Matter blasted from the colossal explosion falls back to the pulsar and forms a disk. Within this chaos, a new world arises, born of fire and destruction. A planetary zombie raised from the carcass of the former red giant star.
It's amazing that planets could form in that environment.
A planet orbiting a pulsar will give you the feeling of being in a disco bar with a very strong strobe light, which is the pulsar.
Radiation from this stellar beast breaks down the organic molecules needed for life.
The pulsar has these very strong magnetic fields that are being spun around as the star is rotating quickly, and it's picking up any material, electrons, protons, and speeding them up and slinging them out at high speed. So it's like a solar wind with a vengeance.
I can't imagine that there would be much of an opportunity for even simple life, microbial life, to emerge and to flourish on a planet around a pulsar. Largely because if you were in the pulse, you'd be severely energized, and if you were not in the pulse, you would be completely devoid of energy.
The discovery of pulsar planets shows how new worlds can form in the wake of a star's destruction. No matter where a planet arises, the process of its birth is fraught with danger. Sometimes, the violence is so great, the end of the world comes before the beginning. 2007. Astronomers using the giant Gemini North telescope make a strange discovery in the Pleiades cluster some 400 light-years from Earth. A star known only by its catalog number, HD 23514, is surrounded by a giant donut-shaped cloud of dust and gas. The star in the middle of the donut shape is about 100 million years old. A cosmic toddler in astronomical terms. Our sun is 45 times older. The conditions are perfect for planets to form. But spectral analysis finds something strange. The dust is utterly pulverized. Typically, a newborn star is surrounded by fledgling planets.
Planets form around the young star in a protoplanetary disk of gas and dust. And then these planets go on their merry way orbiting the star, not realizing that they're in an orbit that's too close to another planet.
Millions of years ago, two primordial planets orbiting HD 23514 are spinning toward doom. As the two worlds close in, tidal forces torque each planet from spheres to egg shapes. Nothing remains. The two worlds are annihilated, creating the dust and debris seen around star HD 23514. 4 billion years ago, a similar apocalypse came to Earth. A Mars-sized planet forms in roughly the same orbit as the newborn Earth. Like the planets at HD 23514, Earth and this Mars-sized body are barreling toward each other.
If you happen to be unlucky enough to be standing on a growing planet when it was in the process of still becoming the Earth, you might wake up one morning and notice that the sky was getting darker and darker as a Mars-sized body was coming at you within a period of less than an hour.
And when it hits, the shock wave is felt all over the planet, scouring the surface of the Earth. The collision obliterates one side of the planet. Molten rock sprays out into space. The entire globe is peppered by meteors and noxious vapor.
It would actually make hell look like a Bahamas vacation.
The debris field from the collision coalesces and forms our moon. It is a new beginning for our planet.
Collisions are part of the birth process for planetary systems. Building up a terrestrial planet is probably all about colliding pieces of rock together.
And all across the galaxy, colliding pieces of rock are forming terrestrial worlds that defy the imagination.
There is a new planet out there, a planet we were not aware of existing before.
It is not just one planet. It is a new type of planet. Earth on steroids.
I like to call them super Earths. They're just like the Earth, except bigger, up to about 10 times the mass of the Earth. One family that the super Earths resemble just like our own Earth. Continents, oceans. Some of them may be very dry, like Mars. And then another family that we call water worlds or ocean planets that are completely covered with water.
Welcome to Gliese 581c.
This planet was found by Michel Mayor, and it orbits with 2 other planets around a very small star.
It's only 20 light-years away in the constellation of Libra and is one of the smallest terrestrial planets found beyond our solar system. That doesn't mean Gliese 581c is small. It's still a super-Earth with 5 times the mass of our home planet. But it's the possibility of liquid water that excites scientists.
An ocean planet feels like being in the middle of the Pacific Ocean, with no land inside, just water, puffy white clouds, and blue sky above you. The winds on the ocean world are going to be similar to that of the Earth. So it will be a very good place to sail.
The weather's absolutely perfect. Every day you get a clear blue sky and the sun just stays in the same place. Now how's that for weather prediction?
No land anywhere. Even miles beneath the surface.
This water layer would extend very far down, at least a quarter of the way down in the planet.
But as we dive deeper into the sea, the pressure builds. At 35,000 feet below the surface, we pass the point where the deepest oceans on Earth bottom out. We pass the 100,000-foot mark. The pressure is so great, water itself begins to take on surprising new forms. At a depth of 10 times the greatest ocean depth on Earth, we reach the bottom.
When you have a large amount of water, then at the bottom of an ocean, you will form very high pressure in excess of 1 million atmospheres. And that pressure will compress the liquid water, that is the ocean, into a state which we call Ice 7.
No, it's not like ice in your refrigerator. The molecules of water that are in the ice in your refrigerator are kind of all jumbled up. But if you form ice under very high pressure, then the water molecules can become ordered, they can become aligned.
I can show you a crystal that is a very good analog to Ice 7. This is halite, also known commonly as rock salt.
Ice 7 may exist within our own solar system. Europa, a moon of Jupiter, could possibly have a mantle of liquid water surrounded by a thick, icy crust. The pressure from the crust is so great that Ice 7 might exist deep within these uncharted seas. If we scale up and thaw out Europa, it could be a water world similar to Gliese 581c.
One could imagine that life could emerge on a water world. After all, water is essential to life on Earth.
Everywhere on Earth where there is water, there is life. You cannot find a sterile drop of water on Earth unless you put it in the microwave yourself.
On this water world, there could be bacteria or any kind of life in the ocean itself.
But not all of the super-Earths are water worlds teeming with life.
When we talk about super-Earths, we talked about two major families of mostly rocky with some water and mostly water with an endless ocean. But one has to add to those a third family of probably very rare super-Earths and Earth-like planets, which are called carbon planets.
A carbon planet is unlike anything we've ever seen anywhere. A place with an alien chemistry, but loaded with very earthly treasures. Throughout our galaxy, there are planets barren and poor and inhospitable. But science is on the trail of a new type of planet, an entire world of treasure.
In our own solar system, in our sun and in all the stars nearby, there's always more oxygen than carbon. But if we think of a place in the universe where there's more carbon than oxygen, then planet formation is very different.
Spectral analysis shows carbon to be far more plentiful, 26,000 light years away near the center of our galaxy. Planets that form here may contain a rich abundance of carbon. The morning sky on a carbon world would be anything but crystal clear and blue.
I'm picturing a yellow haze with black clouds of soot. And as you descended farther down in the atmosphere, I could imagine lakes that were made out of compounds like methane or gasoline. I'm picturing these bubbling, foul-smelling pits of black ooze, like an oil well.
With little or no water in the atmosphere, the air is made of carbon compounds.
Methane, butane, pentane, benzene, all these different kinds of carbon compounds that separate out when you refine gasoline. One day it might be raining benzene. The next day it might be raining butane.
Alien as carbon planets might seem, the air quality could be familiar to some.
The air in a very benzene-rich planet will resemble that of LA. A lot of smog particles that unfortunately we are quite used to from the exhaust of cars.
Despite the pollution, carbon planets could come with a sparkling upside.
You might see diamond because the planet may have substantial quantities of pure carbon that it's formed out of. And pure carbon, when you compress it, tends to form into diamond.
The secrets of exotic planets like these are waiting to be discovered all across the galaxy. But astronomers won't be satisfied until they find the Holy Grail. A planet like our own, one that sustains life, the next Earth.
People always ask me, do I think we're going to find another planet like Earth? And I answer, absolutely.
Every star probably has planets roughly the same size as our Earth.
We think that essentially every star has several Earth mass or super Earth mass planets. So if you have, say, 200 billion stars in the galaxy, that may mean there are 400 billion Earths in the galaxy or more.
400 billion Earths. The Kepler Space Observatory is the first instrument capable of finding one of these planets.
Kepler is looking at the constellation Cygnus in the night sky at 100,000 stars, taking picture after picture after picture, minute after minute. And the goal of Kepler is simple: to look for stars among the 100,000 that dim.
When a star dims slightly, it means a planet passes in front, blocking some of the light. How long the star dims and how much light gets blocked will tell scientists about the size of the planet and the distance from its sun.
A good analogy for this is looking for the dip in the light that you would see from a searchlight if a small moth flew across the searchlight. And so it's a really tiny dip in the light as the planet transits.
It is a very powerful technique because it allows you to discover planets that are even smaller than the size of the Earth around stars similar to the Sun.
It is a technique that is changing the course of science.
We think we may be able to find a planet that is habitable in the next few years.
Scientists estimate the Kepler mission will find a minimum of 50 alien Earths.
One of the big questions that anybody looking for life beyond the Earth is facing today is, what if we don't recognize life even though we discover it?
Conditions on an alien Earth may cause life to evolve differently.
My hope is that we'll see some sign that will make our hairs stand up on the back of our necks.
Whatever that sign is, it will be the first chapter on the greatest scientific story ever told.